Okay, so in this lesson we're going to look at factoring by grouping, but this time we're going to look at problems where we have to rearrange the terms. So the focus will be on rearranging the terms. Now, as a quick review from the previous lessons dealing with factoring by grouping, let's look at this example. So let's look at number one. So let's suppose we had 40r cubed minus 8r squared minus 25r plus 5. And so from previous experiences, you can do this one very easily. So notice that we're not going to rearrange terms here. We're going to leave the terms as they are. And so let's group the first two and group the last two. Now remember, first of all, you need to look for a GCF of the polynomial, which we didn't do. But the GCF is 1. So then since the GCF is 1, we're going to go directly and group the first two and last two. All right, now when I group the first two, what's the GCF of the first two? Well, it will be an 8 because 8 goes into 40 and 8 goes into 8. And this term has three factors of r, and this term has 2 factors of r. So the GCF will be 8r squared. So 8r squared times, now remember when you factor, you're writing it as a product. So when you factor the GCF, it's the GCF times a polynomial. So 8r squared times 5r will give me 40r cubed minus, and then 8r squared times 1, negative 1, will give me a negative 8r squared. Okay, now let's look at the next one, the next group. So the next group, now remember you always want to factor out that middle sign here, so it'll be a negative GCF, and so the GCF here is 5, so it'll be minus 5, times, and then you do the same thing. Negative 5 times what is negative 25r, so it'll be 5r, and then negative 5 times what's a positive 5? Well, that's a negative 1. And so notice that if you look at those two parts, they both have a factor of 5r minus 1 in common, so I'm going to take that out. I'm going to factor that out, so 5r minus 1. And then when you factor out a 5r minus 1, you're left with 8r squared minus 5. So 8r squared minus 5. And then remember, as always make sure that the factors that are left aren't factorable any further. So if you look at 5r minus 1, that GCF is 1. And if you look at ar squared minus 5, that GCF is 1. All right, so that was a quick review of the previous lessons. Now let's look at number 2. So number 2, let's suppose we had 4x squared plus y plus 4xy plus x. All right, so let's suppose we had that. Now, in number 2, if you look at the GCF is 1 here. So the GCF is 1. And then we're going to go directly, just like we did before, we're going to group the first two and the last two. Now, if you look at the first two, see the GCF of the first two is 1, right? And if you look at the other group, the GCF is x. But do you see that if you see the GCF here is 1, you're going to say 1 times 4x squared plus y, correct? And over here, you're going to say plus x times 4y plus 1. That'll agree? Now, here's a question. Just like we did here, you saw where these two parts had a factor of 5r minus 1 in common, so I factored out. Here, those two factors are not the same. So grouping the first two and grouping the last two did not help. So that did not help. So what we're going to have to do is rearrange the terms. Now, the strategic way is this. Always keep the first term as it is. All right, and then you just rearrange the other three terms. Okay, so let's do this. So we're going to keep the first one the same. And I'm going to put the second one, the third term, as a second. So I'm going to say plus 4xy, and then plus y plus x, just like this. Okay? So all I did was I kept the first term the same, and then I just rearranged the other three terms. All right, and if you rearrange it and it doesn't work, you go and rearrange something else. Okay? So you exhaust all possibilities. If you exhaust all possibilities and you can't factor anything, then you say it's prime. All right, so again, we keep the first term the same, and I'm going to put the third term second. I'm going to write this as the third term, and this as the fourth term, just like this. All right? Okay, now let's group the first two and group the last two. In the first group, it looks like I can factor out a 4x. Y'all agree? 4x. So I get 4x times, and then that's x plus what? Y. And over here, that GCF is 1, so I'm going to say plus 1 times y plus x. Y'all agree with that? Okay. Now here's the question, though. Are these two factors the same factor? Yes, they are. X plus y and y plus x. Remember, addition is commutative. So if you want to, you can rewrite this as x plus y. So in other words, I'm going to say 4x times x plus y plus 1 times x plus y. So y plus x is the same as x plus y. Now you see that those are the same. So you can factor that out. So you get x plus y times 4x plus 1. All right? Now that's what happened when I put the third term second. But what if you did this? What if someone said, all right, well, could I have instead of putting the third term second, could I put the fourth term second? All right, let's see what happens. So 4x squared plus x, and then plus y plus 4xy. All right, so you see all you're doing is just rearranging the terms and then going through the process and see if it helps you. So this process here, rearranging the terms like I did here, did help. All right, now let's see what happens if someone else had rearranged the terms this way. All right, so let's look. So we're going with the first two, the last two. In the first group, I can factor out an x, and I'm left with 4x plus 1. In the second group, I can factor out a y, and I'm left with 1 plus 4x, because y times 1 is y, and then y times 4x is 4xy. Now here's the question, just like we asked ourselves this. Is 4x plus 1 the same as 1 plus 4x? Yes, it is. So if you want to, you can rewrite one of these factors. So if you want to rewrite 1 plus 4x as 4x plus 1, go ahead and do it. No big deal. You don't have to. Oops. So what did I say? 4x plus 1? And now you can factor out the 4x plus 1. So I get 4x plus 1 times x plus y. And notice that's the same thing as this. Okay, x plus y times 4x plus 1 is the same as 4x plus 1 times x plus y. Remember, multiplication is commutative. The order in which you multiply does not matter. But then you may ask yourself, well, now, did I exhaust all possibilities? In other words, I knew that having y second and this first didn't help. So I rearranged. I put this second, and then this in that order, and then someone else could have put this second, and then this in that order. What if you had done, let's say 4x squared plus x, just like here, and then just put 4xy first, and then plus y. Would that change anything? I don't know. Let's see. So in this group, I can factor out an x. I get 4x plus 1. Over here, I can factor out a y, and I get 4x plus 1. So the only difference here is that by writing it as y plus 4x instead of 4x plus y, by writing it as y plus 4x, the order here is not the same, but the factors are the same, because 4x plus 1 is the same as 1 plus 4x plus 1 plus 4x. And here, by writing it like this, they're exactly the same order. And so you don't have to rewrite it like this if you don't want to. So you can say 4x plus 1 times x plus y. All right. So there, just keep in mind that there are multiple ways, not always, okay, but there are other ways to rearrange to where it will work. You'll get your final answer. All right. Okay, number 3. Let's suppose we had this for number 3. So number 3, let's suppose we had this. All right, number 3, we have 3c minus cd plus 3d minus c squared. Okay? All right, now notice the GCF here is 1, so always look for the GCF. The GCF is 1. Now if I group the first two and the last two, let's see what happens. So in the first group, I can factor out a c. I definitely can. I'm left with 3 minus d, right? And in the second group, I can factor out the g self here is 1. So you actually have 3d minus c squared. So notice that help. Is leaving it in this order going to help you? No. Now don't say it's prime. You don't know that. You don't know that. You got to rearrange them and you got to exhaust all possibilities before you can say it's prime. All right, so just because the first two and the last two group and the first two and the last two did not work does not mean it's prime. You have to go and rearrange. So that did not help. So let's rearrange. So let's go ahead and remember, always keep the first term first. And let's put the third term second. So plus 3d, and then let's do minus cd minus c squared. So let's do it like that. Okay? All right, so let's see what happens. So in the first group, second group, so I can factor out a 3. So I get 3 times c plus d. Y'all agree? And then over here, I can factor out, remember, always a negative, if that's your middle term, negative c. And I get negative c times d is a negative cd. A negative c times a positive c is a negative c squared. Now here's the question, just like before. Is c plus d the same as d plus c? Yes, it is. So if you want to, you can rewrite this. It does not matter. So you can say 3 times c plus d minus c times c plus d. So this right here is the same as this. And now you can factor out the c plus d. So I get c plus d times 3 minus c. Okay? Now, remember, what I did was, if you think about the previous problem, so I kept, the first group and the last group did not work. So I rearranged. So I left this the same, and I put this second, and then this third and fourth, and just saw what happened. Okay? What if someone had done this, though? What if someone had said, well, could I have instead of putting this second, could I have put this second? Oh, sure you could. Let's see what happens. It may or may not work. You may have to rearrange again, and then just put these in that order. See if that helps. All right, so let's see what happens. So remember, all you're doing is just rearranging, and you're going through the process. So we're going to group the first two, the last two. So if I group the first two, I can factor out a c, and I get 3 minus c. If I group the last two, I can factor out a d, so that's minus d though, and I'm left with c minus 3. Okay? Now here's the situation. Be a little bit careful. It is true. It is true. And let me go ahead and make you aware of that. It is true that c plus d does equal d plus c. That's a true statement. Okay? Just like I'm saying 2 plus 5 is the same as 5 plus 2. Y'all agree? All right. But be careful here. This is 3 minus c, and this is c minus 3. Those are not equal. Those are not equal. That's like saying 5 minus 7 is the same as 7 minus 5. You know that's not true. That's not true, because 5 minus 7 is a negative 2, and 7 minus 5 is a positive 2. But notice those are opposites, right? Those are opposites. Negative 2 and a positive 2 are opposites. So what that means is this. 3 minus c and c minus 3 are opposites. So c minus 3 is the opposite of c minus 3. C minus 3 is the opposite of c minus 3. They differ by negative sign. Is the opposite, I'm sorry, 3 minus c, excuse me. 3 minus c. 3 minus c is the opposite of c minus, c minus 3 is the opposite of 3 minus c, or you can say 3 minus c is the opposite of c minus 3. But what that means is this. You see how they differ by negative sign? Okay. So if you notice that those are opposites, then what that means is this. Now listen carefully. What that means is this. I can factor out a negative 1 from c minus 3. So in other words, I'm going to get this. C times 3 minus c minus d, and then right here right here, I'm going to factor out. Now watch what happens. Let me go ahead and rewrite this. I'm going to factor out this right here. I'm going to factor out a negative 1, and I'm left with negative 1 times a negative c is c, and a negative 1 times a positive 3 is a negative 3. Now I want you to notice, and it's very important to recognize this, 3 minus c does equal, 3 minus c does equal negative c plus 3. That's a true statement. 3 minus c, 3 subtract c does equal negative 3 plus c. For example, okay, listen carefully. Is 5 minus 7 the same as negative 7 plus 5? That's what that's saying. The answer is yes. 5 minus 7 and negative 5 plus 7 are the same thing. That's a negative 2, and that's a negative 2. All right? Okay, so once you notice that those are opposites, then you can factor out negative 1. And then now you got to be a little bit careful, though. You have to be a little bit careful. So then you would have to say c times 3 minus c, and then you see how this is a negative d? So a negative d times a negative 1 is a positive d. So you got to see this. That's a positive d. And then I'm going to rewrite negative c plus 3 as 3 minus c. So just rewrite this like that. And now notice that you have a 3 minus c in common, so you can factor out a 3 minus c, and you get times c plus d, which is this. Now, I'll be honest with you. Now, in a couple more sections, you're going to deal with opposites a lot more. But when students get to this point, they're like, oh, well, since those are not the same, I'm going to try something else. And that's fine. You can regroup. But just know, and this is going to happen quite a bit when you rearrange, you're going to end up with opposites. Whenever you end up with opposites, all you have to do is to factor out a negative 1 from one of these. And it's always strategic to factor it out from the one that has a subtraction symbol right here. And so you factor out a negative 1, and notice negative 1 times a negative c is c, negative 1 times a positive 3 is a negative 3, and notice that those are now the same. So if you want to rewrite it, you can, and then you factor out the common factor. What if someone, though, had wanted to rearrange it, let's say, this way? So let's say you want to rearrange it to where instead of putting, let's say, I'm trying to see which way I could do this. So let's say you wanted to put 3c minus c squared, all right? And then instead of say minus cd plus 3d, let's say plus 3d minus cd instead. All right, see what I did? So I just instead of putting it in that order, I put it in this order. All right. So let's see what happens. So I'm going to factor out a c here, and I'm going to get 3 minus c, and then over here I'm going to factor out a positive d, and I get 3 minus c. Notice how much easier this putting it in this order versus this order. Okay. Now here's the thing, though. And then that's an important thing to see. If you put it in this order and you see that those are opposites, then all you have to do is rearrange these two. That's all you have to do. Rearrange those two, just like I did here, and now you don't have to worry about opposites anymore. Those are now the same. So I'm going to say it again. If you rearrange, and those two factors here are opposites, to get them to be exactly the same, to look exactly the same without having to go through factoring out a negative 1, all you have to do is just switch those terms. Just switch the last two, and now they're going to be exactly the same. And so now you can factor out a 3 minus c, and so when I factor out 3 minus c, I'm left with c plus d. And notice that in all cases, I got the same answer. So So there are multiple ways, many times there are multiple ways of rearranging, okay? But be careful with the opposites. If you see an opposite and you don't feel comfortable at this point with factoring out a -1, then just go ahead and rearrange the last two terms. That's all you have to do. All right, I'm going to see another example in a little while like that. Okay, number 4. So let's do number 4. Suppose in number 4, and let me see if I can find the problem I wanted to do with number 4. So let's suppose in number 4, I had this one. All right, this is number 4. Make sure that's the right one. 2. Okay, so number 4. A squared minus 4b minus 4a plus ab. Okay? All right. Now, so if I group the first two, you see that GCF is 1, right? So you may say, well, I'm going to still look at it. I'm going to factor out a 1, and I get 1 times a squared minus 4b. Okay? Over here, I can factor out an a, negative a. It says GCF here is negative a. And I get 4, what's that, minus b? But those are not the same, right? Those two things in parentheses are not the same. So that didn't help. So let's rearrange. So let's go ahead and just our strategic way, let's go ahead and make this our second term instead. So I get a squared minus 4a, and then this put these two in the order next. Minus 4b plus ab. All right, just do that. Just rearrange and go from there. That's all you have to do. And so when I group the first two then and group the last two, let's see what happens. So in the first group, do y'all see I can factor out an a? So I'll be, that's going to equal a times a minus 4. In the second group, I can factor out a negative b, and I'm left with negative b times 4 is negative 4b, and negative b times a negative a is a positive ab. Now, just like before, guys, those are not exactly the same. Those are opposites, right? Those are opposites. So you may say, well, I don't feel comfortable factoring out a -1 from here and then dealing with it like we did in the previous example. I don't feel comfortable with this yet. Okay, that's fine. We're going to go back then and rearrange those two terms. But if you do feel comfortable going further, then let's go ahead and do it. So let's go ahead and, so you got to recognize that those are opposites, right? A minus 4, note, a minus 4 and 4 minus a are opposites, right? So which means that if I'll multiply this one or this one by -1, I get the other one back. That's all it is, okay? So, but remember, we're factoring, so I'm going to factor out a -1 from here. So in other words, I'm going to say -1 times -1 times 4, -4, excuse me. -1 times a -4 is a positive 4. And then a -1 times a positive a is a negative a. And now notice those two, a minus 4 and -4 plus a, are the same thing. So note number 1, those are opposites, and note number 2, a minus 4 does equal -4 plus a. And so what you would then do, if you did feel comfortable with this, then what you would do is now rewrite this as negative b times, remember this is times right here, so negative b times -1. So I get a times a minus 4 plus b times -4 plus a. And also notice again, those are the same, right? So if you want to rewrite this one to look like this, you can. So I get a times a minus 4 plus b times a minus 4. That's what this is right here. And now I can factor out an a minus 4, and then I'm left with a plus b. Okay? Now again, that's if you felt comfortable. Now, if you don't feel comfortable factoring out a -1 and going through this process, then all you have to do, once you recognize that those are opposites, all you have to do is just rearrange the last two terms. That's all you have to do. So let's do it. Let's rearrange the last two terms. So let's suppose someone got to this point and said, oh no, I don't want to deal with opposites. So I'm just going to rearrange the two terms. Okay, let's do that. A squared minus 4a plus ab minus 4b. All right, so those stay the same. All I did was rearrange those two. See that? Negative 4b plus ab is the same as ab minus 4b. Okay, let's go from there. So first two, last two. In the first group, I can factor out an a, and I get a times a minus 4. In the second group, I can factor out a b, and I get b times a minus 4. So now they look exactly the same, right? And so then you factor out an a minus 4, and you get a minus 4 times a plus b. See how much easier it is? So if you want to, if you recognize those are opposites, and you don't feel comfortable dealing with this, then just rearrange, and then you get it very easily. Okay? All right, and then you could rearrange and possibly some other ways and get the go through the process and get the same answer. All right, but just want you to know that there's more than there's a possibility that there's more than one way to rearrange. All right, just remember the opposites though. If you're kind of worried about dealing with opposites, then just rearrange the terms, and then you don't have to worry about opposites anymore. Okay, number 5. Let's look at number 5. Suppose in number 5 I have let's say, I'll make sure I'm reading the right one. All right, let's say I have this one, number 5. All right, so we have x squared minus 6yz plus 2xy minus 3xz. All right, and so notice the GCF here is 1. Okay, so the GCF is 1. So if you try grouping the first two and the last two, you're going to notice that the GCF here of the first group is 1. So that's not going to look exactly like this, right? So then let's just go to reordering. So to reorder, I'm going to do just like we did before. I'm going to keep the first one the same. I'm going to write the third one second. So I'm going to say now remember rearranging now, okay? So we're going to rearrange. So I'm going to say x squared plus 2xy, and then just put these two as you see it, minus 6yz minus 3xz, and then go from there. Okay, no big deal. It's not that bad. Now we're going to do the first two and the last two. So in the first group, I can factor out an x. So I get x times x plus 2y. Y'all agree? X times x is x squared. X times 2y is 2xy. In the second group, I'm going to factor out a negative, and then that's going to be a 3z, right? So 3z. And when I factor out 3z, I get negative 3z times y is negative 3yz. A negative 3z times a positive x. Oops, I'm sorry. That should be 2y, right? 2y, excuse me. Negative 3z times 2y is a negative 6yz. Okay, and then negative 3z times a positive x. Is that correct? All right. Now look, are those the same? Yeah, those are the same. X plus 2y is the same as 2y plus x. So if you want to rewrite it as that, then that's fine. So I get x times x plus 2y minus 3z times x plus 2y. All right, so notice that that's the same. Now I can factor it out. So I get x plus 2y. So when I factor out x plus 2y, notice I get x minus 3z. All right, and that's all you do there. Now, let's suppose someone else rearranged it like this. So let's suppose someone else had said this. So this is still number 5. So rearrange. So let's suppose that instead of putting this second, they put this second. All right, no big deal. Let's see what happens. So x squared minus 3xz, and then let's say, and let's put these two next. So minus 6yz plus 2xy. Okay? All right, so again, it doesn't matter in the order in which you rearrange. If it doesn't work, you rearrange it a different way. And if you get opposites, just remember we did. If you get opposites. All right, so let's group the first two, the last two. So in the first group, I can factor out an x, and I get x times x is x squared, and then x times a negative 3z is negative 3xz. Over here, I can factor out a negative, and that's going to be a 2y, right? 2y. So I get negative 2y times 3z, negative 2y times 3z is a negative 6yz. A negative 2y times a negative x, a negative times a negative is a positive, and so that's going to give me 2xy. All right, now look at what you have. Are those the same? Is x minus 3z the same as 3z minus x? No, they're not. But what are they? They are opposites. They are opposites. Good. So if you want to deal with factoring out a negative 1 and you feel comfortable, do it. If you don't feel comfortable, then what is it you got to do? Do you remember? So if you don't want to deal with these two as opposites and factor out a negative 1, what is it that you want to do? You want to rearrange those two terms, those last terms, just rearrange them. So we're going to do that. So let's just go and let's go, because you really need to know how to factor out negative 1. At some point you have to do that. So let's just go ahead and do that now. So let's factor out a negative 1 from this factor here. And so when I factor out a negative 1, I get negative 1 times a negative 3z is a positive 3z. A negative 1 times a positive x is a negative x. Okay? And now notice x minus 3z is now the same as negative 3z plus x. But what you got to do, though, you got to rewrite this right here. So a negative 2y times a negative 1, so it becomes x times x minus 3z is a positive 2y. And then if you want to rewrite negative 3z plus x as x minus 3z, you can. To make it look like this, you can do that. So notice that this is this. So now we can factor out a x minus 3z, and then you're left with x plus 2y. Okay? So if you feel comfortable factoring out negative 1 and going through the rest of this, then that's fine. If you don't feel comfortable, then what I would then do is just rearrange the last two terms over. And then you don't have to worry about opposites. But you do need, before we get into the next chapter, you do need to be able to deal with opposites. Okay? All right, so let's suppose someone got to this point and saw that those were opposites, so they're going to do this. They're going to say, well, I'm just going to rearrange the last two terms. All right, let's do that. X squared minus 3xz plus 2xy minus 6yz. Okay, so all you did, once you figure out their opposites, all you do is rearrange. That's all you do. And watch how simple this becomes. So group the last two, group the first two, group the last two. So in the first group, I can factor out an x, and I get x times x is x squared minus x times a negative, what's that, 3z, is a negative 3xz. Over here, I'm going to factor out a positive, and that's going to be a 2y, right? Times, and then 2y times x gives me 2xy, minus a positive 2y times a negative 3z gives me a negative 6yz. And then now notice those are the same. See how simple that becomes? It's not difficult. So then you can factor out an x minus 3z. And then when you factor in x minus 3z, you're left with x plus 2y. And you're done. Okay? All right, so that was number 5. Let's see if we have time to do another one. Let me just check real quick. Okay, so let's do one more. Let's do number 6. Number 6. All right, number 6. So we have in number 6, we have 12x cubed plus 6x squared plus 5x plus 10. Okay? So I have those four terms. The GCF is 1. So then if I group the first two and group the last two, let's see what happens. In the first group, I can factor out a 6x squared. And so I get 6x squared times 2x gives me 12x cubed plus 6x squared times 1 gives me 6x squared. And then over here, I can factor out a positive 5, and I get 5 times x is 5x, and then 5 times 2 is 10. And if you look at those two factors, are they the same? No, they're not the same. All right, so then that didn't help. So let's rearrange the terms. So let's put the third term second, see what happens. So we're going to rearrange. So if I rearrange, I get 12x cubed plus 5x, and then plus 6x squared plus 10. All agree? All right. So if I group the first two and group the last two, let's see, I can factor out an x, and so I get 12x squared plus 5. Obviously, you know it's not going to work, right? And over here, I can factor out a 2, and I get 3x squared plus 5. And so that didn't help. So rearranging that order did not help. So that order didn't work. Putting the third term second did not work. So let's put the fourth term second, see if that works. So let's rearrange again. So I got 12x cubed plus 10 plus 6x squared plus 5x. Now once you let me just say this. Once you go through, if the first order did not help you, and you put the third second and that didn't help, and you put the last second that didn't help, then you pretty much exhausted all possibilities. Just keep that in mind. So notice that's not going to help either, right? Because it over here the GCF is 2, and so I get 6x cubed plus 5. Over here the GCF is x, and so you get 6x plus 5, and so that didn't help. So you pretty much exhausted all possibilities. So then we say that this is prime. So this cannot be factored. So the answer you'll say is prime. Okay, now remember, prime means it can't be factored. That's what that means. Okay? All right. So keep in mind that if you when you not all polynomials are factorable. Okay, so we saw that in previous lessons. So we say it's prime. But in terms of grouping, when you exhaust all possibilities and nothing works, then you just say prime. At that point, you say cannot be factored. Okay, so that's going to take care of that lesson. So that's the end. So remember, this lesson, though, just keep in mind. So this lesson is where we had to rearrange terms. Oh, and also keep in mind that when you deal with opposites, if you don't want to have to deal with opposites, all you have to do is just rearrange the last two terms, and then those two will be exactly the same. Okay? All right, so that's the end of this lesson.